Welcome to Building Connections, presented by IPEX. Each week, we delve into the world of construction, exploring how key leaders in the space shape the infrastructures of tomorrow. Discover the stories behind the solutions that impact municipal, commercial, and residential projects across North America.
Welcome to Building Connections, the podcast by IPEX, where we explore the people and the ideas shaping the future of infrastructure. I'm your host, Greg Blackett. So in this episode, we're joined by Michael Clark. Michael's the Director of Field Engineering at Rogers O'Brien Construction, a company leading the charge when it comes to construction innovation. From drones to digital modeling, Rogers O'Brien is rethinking how buildings come to life. So Michael's team is at the forefront of bringing technology into the field. And today, we're going to talk about how they're doing it, what's working, and where does Michael see the industry heading next? So let's jump in. Afternoon, Michael.
Afternoon. Happy to be here.
Well, we're super excited you could be here, and I'm kind of pumped up about this because we haven't spent a lot of time on the show talking about technology and the role it's playing in the construction industry. So I'm really excited about this. But before we get into that, Michael, maybe just introduce yourself, kind of what got you into the construction industry and what led you to Rogers O'Brien.
Oh, yeah. Happy to tell my story. I started in construction right out of high school. I mean, that was something that a lot of people in my industry haven't done, especially getting to that level that I am today. So I started back in 2003. Wow, man, I've been getting old. But yeah, so I started out general labor, worked my way up through the ranks as a carpenter foreman with a company called Hensel Phelps. I'm sure you've probably heard of them. They're a very large company. And then back in 2012, I moved back to Texas, my home state, met my wife, and wanted to kind of settle down and stop the moving around. So I got a position here at Rogers O'Brien as a field engineer, and have worked my way up to director of field engineering, actually helping the company, pull field engineering out of our operations department and making its own separate support department for the company. So that's pretty much my story. I mean, it's been exciting, right? It has not felt like 20 some odd years. I'll tell you that right now.
Yeah, that's incredible.
I don't know when I went from being the young kid on the job site to the old man, but man, that was just something that doesn't really happens overnight.
We all get to that point where we look back and we're like, now we're in charge. So it's pretty exciting. But maybe just also, I know, Rogers O'Brien's quite well known in Texas. Maybe just kind of share for everyone a little bit more about what you guys do there and maybe the types of projects you work on.
Not a problem. Yeah, we're in quite a lot of different business units, everything from healthcare to data centers, high-rise apartment, churches, all kinds of different business units.
Yeah.
We started back in 1969. It is a third-generation family-owned general contractor here in Texas. We only operate in Texas and have no designs of leaving Texas. Our whole mission statement, I guess, is to be the premier builder of Texas. I mean, and that's kind of where we base everything around of, being that premier builder in Texas. A part of that is innovation. We were one of the first to adopt iPads in the field as a company. We've started drone surveying. We just started our own reality capture support department, and Miroscape, which is more of a direct to owner service. So that's always fun. That's going out, doing laser scanning, 360 photo capture, things like that, directly for owners, separate from contracts and things like that, or separate from our projects and everything.
Yeah, and that's how I know Rogers O'Brien is sort of the innovator in the space. And you guys work on all kinds of projects, like you mentioned, hospitals, institutions, multifamily, dwellings. Let's jump in the technology piece. So maybe just let's talk about what technologies that you think are really making the impact now on some of the more recent job sites that you want to talk about and highlight.
Oh, yeah. So, I mean, one of the ones for especially my department, We started using laser scanning for verification in field. So utilizing a program called Verity made by ClearEdge, and it's kind of revolutionized how we do as-builting in our field. We're able to go out and with a LiDAR scanner, scan an entire floor, concrete floor, whatever, and get that information into the office, run a report all within the same day. That has completely changed the game as far as verifying in field, because now I have a full 3D point cloud that we collected that morning, and by that afternoon, I'm able to hop on a Teams call or go out to the project, sit down with the project team saying, hey, here's what's going on your project. Here's what's installed correctly. Here's what needs to be changed. Here are things that aren't quite aligning. And we can make those adjustments right then and there before trade partners have to get involved, before it starts impacting schedule. Because, I mean, I don't have to tell you guys, but, timing is the name of the game for construction. If once it starts impacting schedule, that's when the dollars start adding up. So,
And maybe before you guys did that, so kind of walk us through what you would typically do, and then what does that mean in terms of like time savings and kind of what you see the benefit. I mean, you already sort of highlighted it, but
oh yes. So as far as that goes, beforehand, like before we had laser scanning, Verity, things like that, it was traditional as-built surveying. We'd go out there with a total station, tape measure, and collect all this data manually, like measuring from grid lines or shooting in uh, offsets of columns and walls, having to put that onto a CAD file, pull all of our dimensions manually. And even then, you're missing, is it twisted? Is it out of plumb? And then, oh, let's go back with a 4-foot level and let's check everything. And you're talking, to check every single element on a high-rise structure. I mean, you're talking days. And then comparing it floor to floor and trying to keep that information straight, comparing it floor to floor, it was nearly impossible. And now, since we have a laser scanner that can tie to control in the building that we're setting, we can compare floor to floor. I can check to make sure things like plumbing sleeves, elevator shafts, all that fun stuff is aligned, plumbed up through 30 stories. And if it's off, how much is it off? Is it skewed? Is it twisted? I mean, that right there alone, along with now, we've kind of coined this term called wet scanning. And it's something that's kind of kicked off here at Rogers O'Brien. And it's really cool because with our laser scanner or LiDAR scanner, we can come out while we're pouring a concrete slab, a concrete deck that needs to be flat, scan it as soon as they get done finishing it, and be able to tell right then and there within 2 minutes, is it flat? Do I have dips? Do I have humps? And be able to get the concrete finisher back over to that area to fix it before the concrete gets hard.
that's incredible.
Yeah, so that saves us time on floor prep, things like that, coming back in with Ardex and had to refill in all that stuff. And we know it's right before it's hard. That's very, very impactful on our
And you trust
projects.
it, like the accuracy is there. Do you spend a lot of time reviewing it before, or you sort of you're so happy with the results that you trust it immediately?
Oh, we've done several piloting studies and everything like that with it, and we have yet to find any major errors like that. And you know how it is. We tell a trade partner, hey, this is low over here. They're going to come back and check it with their equipment because their equipment, is just a rotating laser, and they're only checking every so often. And I tell them, hey, this 5-foot square around this column is high 1/2 inch. They're going to go check with their equipment, and they've always come back and like, yep, it's high. We're going to screed it down. We're going to make it level. And it's really impacted our projects going forward because when we do this, the first time we have a lot of errors, they come back and fix it. But every subsequent pour or placement, they get better. They get more accurate. They take the time to actually do it right the first time because they know we're checking it. And that's been super helpful in our projects. And, just putting out a building that's right the first time that we don't have to come back and fix.
Mm-hmm. Yeah, that's great. And you guys also use a lot of drone work in
Oh,
your field operations. Maybe just talk to us a little bit about when do you start using drones and how do they help you guys in the process?
oh yeah. We've been dabbling in drones since the early 2000s. As of right now, we're using a program called Propeller Arrow, and that's a full-on drone surveying platform. It's something that helps our field engineering teams out there on the sites be able to collect data faster, but it's also assisting our project teams in correlating that data into something useful. So all of our information that we collect with the drone, which I can go and send a crew out there to fly we'll call it a 25-acre job site. They'll fly the entire 25 acres in 15, 20 minutes, collect everything that drone can see. You're talking everything that's out in the open. We'll put that into the platform. It'll take about 6 to 8 hours to process. So usually by the time we get to work the next day, it's already processed in the platform, and everything processes to our coordinate system. So whatever's in the platform aligns with what we're laying out in the field, what we're coordinating all of our BIM models, CAD files, everything like that too. So everything's working in the same world. For those of you who don't know what, coordinates are and everything, it's just our position in the world. It registers and makes sure everything overlaps with each other. What that helps us do is we can import 3D surface models, CAD files, and actually check what's out there in the field to what the design was and get accurate measurements from it. So we can track how much dirt we're moving around on site, week to week, day to day, in between flights, whatever, and have an accurate model of, okay, well, we've brought in 2,000 yards of dirt in the past week, or this building pad is now 1 inch from design, and keep track of that. And as the job site goes on, we can see, well, someone got on this building pad and we can see who it is, and they didn't remove their spoils. Cool. Now we know who to go back to tell them to remove their spoils, and that's helping our project management staff. Then our superintendents on the site can go in there and say, let's pull up the latest flight, overlay our foundation file. Let's check to make sure piers and grade beams are going in accurately. And they can pull it up. And with the systems that we have in place for quality control, we're seeing residuals of 1/4 to 3/8 of an inch on the horizontal plane and about 1/2 to 5/8 on the vertical plane. So you can legitimately check form work with this. And one of our more recent ideas with using Propeller is for high-rise structures. So, everything's centered around high-rise, got to make sure it's plumb, got to make sure everything's going right, going up. Cool. We're doing a pre-pour inspection using Propeller, where we'll come out after they get everything on the deck, fly it. It as-builts all of our plumbing, electrical, sleeves, blockouts, PT cables, conduit, form edge, core walls, everything. And since it's all registered to our coordinate system, I can overlay our CAD files directly on that and see, hey, do they have all of their plumbing sleeves in place? Are they in the correct place? That way, you don't get the dreaded plumbing sleeve coming up, half in and half out of a wall. Nobody likes that. But with that, I'm sure a lot of people that listen here who will understand, you get 10 floors up on a high rise. Design team comes back and says, hey, we forgot a vent pipe. We're going to have to come back through and core 10 floors for this 3-inch vent pipe. And you're like, oh, great. Let me get the scanner guys out here to scan to see where my PT cables are, where my rebar is. Well, this is so accurate that I can see rebar. I can see PT cables. So you tell me where you want to drill this vent pipe, and I can tell you if there's PT cables in there from the computer, have it on a Teams call with the design team saying, no, there's a grouping of PT cables right there.
That's really cool.
And then I can, if we really needed to, I can take that information out of Propeller, all that line work for PT cables, put it back into my field team's hands, and they can go lay out where those PT cables are, where those conduits are in the field seamlessly without a whole lot of rotating and translating and taking it back and forth. It's just trace the line work, export directly to them, and then go lay it out.
Go for it.
This is all about that speed of information. So that's really helped us with verifying and making sure things are input correctly the first time. I mean, that's the whole big thing with GCs. As a general contractor, you want to make sure it's done right the first time.
Yeah, absolutely. And the other areas maybe to talk about in terms of technology, you mentioned BIM files, digital twins. Is there anything in that area that you guys are seeing that you're taking on recently or doing that's a bit new or novel?
Yeah, so we're actually working with a company called Cupix. We're trying to get I call it the grand prize, but it's being able to go out there with the 360 camera, capture data on a regular basis, and then compare that not only to our BIM model, but to our schedule. That's the ultimate digital twin for construction right there. That's where we're trying to get to where not only can we see, hey, is it installed per design, but where should we be at per schedule? How
Okay.
much of this duct work should be installed, and being able to actually break that down to analytics and say, hey, we're we should have installed an additional 250 linear feet of this pipe by now.
And it does it automatically, like it takes a photo and then it references the schedule digitally, and then it spits out a gap report or something like
Yeah.
that. Yeah.
So it's turning our BIM models into a 4D BIM model. So it's pretty complex, and we're trying to get it all fine tuned and everything like that before we start pushing it out. But
Mhm.
that is one of the cool things we're working on. So yeah,
That's really
more
cool.
to say on that. Yeah, because that's where you want to get to. Because we're trying to develop this. We're calling it the ROCC, Rogers O'Brien Command Center, where you have a very seasoned, what we call a field director, overseeing 3 or 4 projects, and they have everything up on a screen to where they can go and check in on the progress of a job site, and using passive data collection to say, hey, we're on schedule, we're not on schedule, and having, you know, an AI, compile all that data and saying, yeah, you're on schedule on this job. This job's 2 weeks behind. This job's, needs help. And that way we can really streamline how we do construction.
And that's new, right? Because
Oh
th
yeah.
that's all very manually traditionally, and you mentioned AI, so let's maybe go there a bit.
Yeah.
Like, do you see AI as ho it's gonna help you in some of these areas, but maybe just talk about where you see it immediately helping. Are you using it today? If so, whereabouts?
Oh yeah. I mean, we're using it in everything from, you know, our RO playbook for, mandating process and training on process. We're trying to get it installed more in our project management software so we can see where our pain points are. Are we behind in schedule? Do we need more submittals? How's our RFIs going along? I believe we're using a program called Smart PM to help us with that, to give us a grading structure based on certain uh, items in a given parameter, and giving us a overall project health grade. So we're already using like assisted AI. Now now you're gonna start getting into like the future of construction, within the next, I'd say, 5 years, you're gonna start seeing a big leap in construction automation with things like, I'm sure y'all have seen HP Site Print, where, it's robotic layout. You're gonna start seeing a lot more passive data collection software so it can just pump massive amounts of data into an AI, and it can be able to read your project essentially. There's I've actually personally talked to a few people who are developing estimating software using
Oh,
AI.
yeah. Yeah.
You know, that's pretty ingenious, and it's we're trying to take in all this mass amount of data that we're collecting from field, and all these reality capture departments, field engineering, just all this mass amounts of data, and how do you correlate that into something that is useful? Picking apart the information. You know, I mean, it'll be the Power BI of the construction world.
It's incredible. Yeah. Yeah, and there's this billboard I saw recently. It was online. It was like, AI can't take your job, and it was an ad for a trade school, and, because AI can't, it's not a physical thing yet, but I started thinking about what you just said in terms of robotics. Um, are you there yet in terms of what can robotics do, yeah, on the job site? And let's talk about that a bit.
Oh yeah, so we recently piloted a new product by Hilti. It's called the JBot, It's something that a lot of companies are really hesitant to, start up, but we had a lot of success with it. And basically what it is, it's a robot that will go and drill overhead anchors. Yeah, and it lays it out and drills it, one machine, super simple to use. And realistically, it was as fast or faster than a 2-person, 3-person team going and doing it manually. But this way, we don't have to have anyone up on a ladder, overhead drilling for 8 hours with a hammer drill. We don't have to have a crew down on the slab laying out all this stuff and lasering up to the top. It does it all for you. It rides around. It doesn't even need a slab. Like, we could just have rough cut dirt down there, and we can go ahead and get ahead uh, on our overhead, which, I mean, that just speeds up your schedule. Like, oh, you can go ahead and have your overhead already installed. I
Yeah.
mean, we're going to be publishing a white paper probably within the next few weeks on it. So
Oh,
be on the lookout for
interesting.
that. Yeah. I mean, it's a great robotic tool.
Yeah.
Now, you got to get past the whole construction workers don't typically, I don't want to say this nicely. We're not usually the heads of innovation, and
Yeah.
we don't like to change. I mean, you look at it, construction really hasn't changed a whole lot in 100 years. We've added motors to stuff and, things like that, but how we do construction's very similar to how we did construction 100 years ago. I think robotics, AI, all those things, they're gonna they're gonna force that change. They're gonna force companies to relook at how we do construction. From JBot to HP Site Print. I mean, there's companies overseas that can do an entire uh, deck pour with 3 people and a few robots. Something that normally takes 40 people, you're going to condense down to 3. And I like what you said earlier, oh, robots going to take your job, because that's always the big worry. Everybody's like, oh, robots are going to put a lot of people out of work. I'm going to tell you right now, construction is going to be needing a solution for all the people leaving construction. I'm sure it's no surprise to anyone in the field what the average age of a construction worker is right now, especially trade workers.
It is probably the number one theme on this show that comes up time and time again. No matter who I talk to, engineer, the tradespeople, yeah, they're all, mid late 40s and above. So you're right, it's a labor issue, a skills gap. And so what you're saying is that these are the tools that are going to fill the void. And if we want to get ahead of the construction demand that we've got coming, right?
Yeah, I mean, most of the people in the construction industry are in the baby boomer generation. Within the next 5 years, they're going to be retired or not physically able to do this work anymore. So you have 2 things leaving. One, you have just the bodies leaving the field, no one to replace them. 2, you have the tacit knowledge leaving the field. What we're calling what we here at Rogers Brown, we call the art of construction. All that knowledge you've gained over the past 30 years of how to build, we're losing that because those people aren't able to be in the field. Robotics, AI, being able to do machine learning and using robots to allow those people with all that tacit knowledge to stay in the field, to help pass down that knowledge to the next generation. And the robotics is going to help us do that. It's going to allow us to bridge that knowledge gap of, okay, we have someone who's fresh out of high school or fresh out of trade school. How do we get them to being productive and competent in 3 months, not 3 years? That's where robotics can come in. And you know as well as I do that the newer generation is going to love coming in with robotics versus coming in with the hammer and a tape measure.
Well, it's interesting because I was going to ask you, because your job is got to be hard in the sense you're always looking at new technology and you've got to trial it and implement it, right? You've got it somewhere along the line, someone has to say, let's go with it. We're going to go from what we used to do to what we're doing, what we want to do moving forward. So just talk, how do you like get change happening at Rogers O'Brien? How do you get people on board your journey?
So We've piloted all kinds of technology from, like I said, SitePrint to JBot, Argyle, Qpix. We pilot all kinds of things. We also team up with other GCs around the country to, compare notes. They might trial one product and we'll try out their competitor and see which one works better. That's where we've developed a lot of good collaborating relationships with other general contractors, even some of our competitors, and just to kind of overcome this technology gap. But I like to use the two S's of implementation. Is it scalable and is it simple? When I'm piloting, those are the two main factors I look for. Is it simple enough to where I can get someone using it within a few days, a few hours, a few weeks? Like, what's that lift on training someone how to use this new piece of technology? And then is it scalable? I mean, it could be the best product in the world, but if I can't scale it across 50 projects in 5 regions in Texas, I can't really implement it. I mean, we've seen a lot of great products that just die on the vine because you can't scale them. I mean, look at the robotic quadrupeds. You have some that are $40,000. Great tools, really innovative, could enhance construction in that passive data collection. But I can't put a $40,000 piece of equipment on 40 job sites or a $50,000 piece of equipment on 40 job sites. So, okay, it's that scalable function. So that's what I look for when we're talking about implementation. And then it just goes down into once they've passed those 2 check marks, okay, let's start a more in-depth piloting, or let's try it on one project and do the whole crawl, walk, run.
Yeah.
Let's find a project where we can use this on. Cool. Let's go out there, use it, see if it works. And then let's see if we can then start slowly scaling it up. That's how we did with Propeller. We started Propeller 3 years ago, just here in Dallas on a few projects, and got the workflow down. We figured out, okay, this is how we're going to scale it across the company. This is how we're going to manage it within all of our projects, how we're going to get recuperated, all that fun stuff. Got the workflow down, got the accuracy under control. So we actually exceed their standard level of accuracy because of our workflow, and we created it. Propeller traditionally is a earthwork survey platform that a lot of your earthwork companies, mining, waste management companies use them. We were one of the first big construction companies to utilize Propeller for vertical construction. And we kind of pioneered a few of the workflows for checking foundations, elevated work. And we did that by, okay, let's get it all working in Dallas. We didn't even tell project teams. We were just saying, hey, we're going to fly your project. We got it all worked out inside our department, in-house, to where once we actually launched it, it was a success. We didn't have to worry about troubleshooting. We didn't have to worry about things not going right. And that's where I see I see things on LinkedIn where, they launch it too quickly.
Yeah.
And it doesn't work because you only get one shot with project teams. I hate to say it. If they use it, it doesn't work. I'll never use it again. It's done. I tried that 10 years ago and it didn't work.
Right.
Okay, well, a lot's changed in 10 years, or 2 years, So I try to make sure that when we start piloting and implementing, it's as low impact to the project as we can make it. And we work out all the kinks, get all the workflow done, and then we launch company-wide. Same thing with laser scanning and, field verification using laser scanning. We just started doing it. We picked a few jobs, a few of our high-rise project. Okay, let's go do it. We don't even tell the project team. We're just going to go out there. We're going to work it into our workflow, see how it impacts our workflow. And if it increases our speed, decreases it, how we're going to, work this into how we build. And we got all that done. And now we're like, hey, so here's a new service. I'm planning on, hopefully later on this year and the next year, we want to start looking at robotic layout again. We looked at it in the past. Still need a little bit of time in the oven, but you know how technology is. I mean, that was a year and a half ago, almost 2 years ago. A lot's changed in that amount of time. I mean, this stuff just changes every 6 months, it feels like.
And so what do you think, let's just say 5 years out, it's a lot, it's a long time, but you've got a good handle on where you see things going based on technology, where you'd like it to go as well. So if we're having this call 5 years from now, how different does your role look, or actually your team's role? Like, is it incremental improvements, or do you think it's a huge change? I don't know, 5, 8 years, whatever it is.
I think in the next 5 years, you're gonna have what I call the light bulb moment. It's everything up until now, most of our innovation in the construction has been to enhance existing technology. We made shovels into backhoes. Cool. You pretty much put a motor on a backhoe. We put a motor and a electronic distance measurement on a total station very similar to what we did back in, 150, 200 years ago, back when the days of Lewis and Clark traversed the nation. I think with the next 5 years, we're going to see that whole shift to where it's going to be something completely different. I call it the light bulb moment because everything up until the invention of the light bulb was an enhancement on the torch. We went to candles, lamp oils, things like that. Well, when they invented the light bulb, they threw away the torch. We're not even going to make the torch better. We're inventing something completely new. And with robotics and AI, that's where we're going to. We're going to completely change how we do construction and how field engineering fits into that. We are, I guess, we're at the center of how things go from a digital world to reality. So you have VDC, BIM, whatever you want to call it, over here, building things inside the computer. We have to get it out of the computer into the real world to build. Surveying, field engineering, layout, whatever you want to call it, that's that process. So we say, hey, this is a known coordinate, this is a known coordinate, this is how it overlays, and telling robots and AIs, okay, this is where you are in the real world, to give them a starting point of saying, hey, okay, this is where you are, now start building. I mean, so in 5 years, yeah, construction is going to look, I'll say this, I personally believe construction will look very different. You're going to start seeing field engineers showing up to a job site, and instead of just deploying a total station, laying things out, we're going to be deploying robots. We're going to be deploying a drone to go do a flight, deploying quadrupeds to go collect data inside the building, deploying things like HP SitePrint onto a project to go do our layout for us, setting up controls for earthwork equipment to start digging on its own without an operator. A lot of this technology is already invented. It's getting the buy-in to implement it in the field. I mean, I was at World Construction last year, or I guess earlier this year. No, it was last year. Sorry, it was last year. And they have tracos that can operate themselves without an operator. You set up machine control. Very soon, you're going to have, robots that can pour concrete and finish concrete on its own, hang sheetrock. I mean, look at something as simple as putting in a plumbing sleeve. That is a very repetitive task that doesn't require a large level of skill to do. You could easily come up with a robot to install this sleeve. Hey, this is in a CAD file or in a BIM model. It's a 3-inch sleeve. Cool. Installs a 3-inch sleeve, installs a 2-inch sleeve, a 4-inch sleeve, whatever it is. But field engineers and layout professionals are the ones that are going to be saying, okay, robot, this point is this point in your CAD file. This point is this point in your CAD file. Now you know where you're at inside the world, inside our project. Go start installing. I mean, so
We're so close, right?
we're so close.
You've got all the data, and the AI tools are there, and the robots are sort of coming, and that's what's probably going to swing it over, right? Once you have a capable robot that can read that diagram, then can do all kinds of tasks. Yeah.
And you're going to start seeing, once you start getting the buy-in, I think it's going to be that snowball effect of, all it's going to take is one or two, big name companies to hop in as early adopters and say, hey, we're going to do robotics, and we're going to have robotics building, assisting the building of this building. And everyone's going to see what a success it is, and it's just going to snowball from there of like, okay, now you're going to get more investors, more implementation, and it's just going to go from there. And I believe in 5 years, yeah, you're going to have robots doing at least 40, 50% of your work on a project. I mean, I know a lot of people are really scared of that, but you're always going to need that person there for QC validation to make sure that the robots are installing correctly, doing what they're supposed to, lining them out, making sure they're working in the right world, and not, because a robot can't think for itself yet. You're going to have to tell it where it's
the
at.
roles are
and
the
how to
roles
go.
are going to evolve. They're going to be
Yeah.
different, right? It's
Well,
we still need people to manage the systems and the tools.
exactly. But
Well,
now,
go
Oh,
ahead.
I was going to say, but instead of, the 60-year-old master plumber with 30 years of experience having to carry around all of this pipe and bend over and do all this installation, he's going to have a robot that can help him, and he can just supervise the robot and say, nope, yep, that's good. Nope, come back, fix this. So that's going to help us keep that tacit knowledge in the field.
Yeah, and you kind of already said it too with the declining workforce and the demographic shortage. It's gonna be required, right? Otherwise, it's gonna be very difficult to move a project along. But I agree with you. Like your vision in 5 years, I think it makes complete sense because you're seeing that across the board, not just in construction, but other industries as well. Um, but it's almost scary to think about, but at the same time, it's pretty interesting because it's solving a pain point and a gap that we're gonna have. So should
Change
probably
is
be
always scary.
yeah, change is scary, but this should be, I think, looked at positively.
Mhm. It should definitely be looked at positively. I mean, we've all seen the statistics on, how many people we're currently missing in construction, and how that's just going to increase over the next 5 years as, baby boomers and everyone retires or isn't able to work in the field anymore. So yeah, you need something to fill the gap. And right now, robotics is what we're trying to fill the gap with because we can't get people to come into the industry.
Well, Michael, this has been really cool, and I appreciate all the comments and you sharing what you guys are doing at Rogers O'Brien. Is there anything else you wanted to share or talk about before we sign off?
No, no, that's pretty much what we're working on so far over here. I mean, we have Reality Capture doing a lot of stuff, or we call it Mirrorscape. Mirrorscape's our direct to owner service. They're implementing a lot of things using the Naviz, VLX, MLX, scan to BIM services. So they're making a lot of advancements on that. Now it's just tying all this stuff into one cohesive workflow, from design build to layout to construction to as building and then into facilities management, the full gambit. That's what everybody's trying to work on now.
That's the next step, right?
That's the next step.
Well, very cool. And like I said, I appreciate you coming on. So good luck, and we'll see you in 5 years, maybe.
Hey, there we go.
Thanks for tuning in to this episode of Building Connections. You can find links to all of the resources mentioned in today's episode in the show notes. If you're finding value in our podcast, please take a moment to subscribe and leave us a 5-star review. It really helps us connect with more listeners like you. Don't miss out on future episodes. Keep listening and building connections with us.